Hello, scholars. We're going to learn a little bit about trigonometric functions today. This is in 9.1 on page 462. There's a nice page on your book. I thought it might be better to just draw these things for you because I'd like you to put them in your notes and draw along with me. The first thing we're going to do is we're going to consider that these are all having to do with the right triangles. So, first premise, right triangle. Second, we're going to label the sides and the hypotenuse. The hypotenuse is always across from the right angle. Always, always, always. Now the other two we've always been calling legs, and these have been called legs interchangeably. But now what we're going to do is we're going to relate the angles to the legs. So, in this example, what I'm going to do is label one of my angles. Let's say this one, theta. And this theta is connected to this side. So because it's connected, we're going to call this side adjacent. We're going to call the other leg that is not connected, in other words, completely away from theta, we're going to call it the opposite side. Okay, opposite. If the angle were in the top, the legs would be switched. So for right now, this is the definition we're using. The hypotenuse is always across from the right angle. The opposite is the side that is totally not attached to the angle, and then the adjacent is always the one that's basically attached. So we're going to define 6 different ratios that we can write in this right triangle. And we're going to refer to these sides. The first one is called sine. And we always abbreviate it SIN. It's SINE if you want to write it all out, but sine. And what we're going to do is we're going to define sine of theta to be equal to the opposite side divided by the hypotenuse. We're also going to have another one called cosine, and again, we're going to abbreviate it, called cosine. And cosine is where we write the length of the adjacent side divided by the hypotenuse. So as you can see, they're just ratios, one number divided by another number. The third one then, because we're going to do 6 total, this one is called tangent. And usually we just write tan, the tangent of theta, is equal to the opposite side, opposite divided by the adjacent. These are the 3 basic most important ones. So I'm going to stop here for a second and give you a chance to write them down. Okay, so the easiest way to remember this is with a little acronym, because you don't always want to write out all those words. You may hear this often. It's so, ka, to, It's just a quick way to remember that sine theta is opposite over hypotenuse. Cosine is adjacent over hypotenuse. and tangent is opposite over adjacent. Okay, so SOHCAHTOA. 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 You'll never go wrong if you remember that. Now, you may ask yourself, what if I turn these upside down? Like if I had the hypotenuse over the opposite, the hypotenuse over the adjacent over the opposite. Those are our other three functions, okay? And so those are exact inverses. And so the inverses, I'm going to write in a different color. The inverses are going to be, for sine, it's called cosecant. So cosecant is exactly upside down or inverse. It's hypotenuse over opposite. The inverse of cosine is called secant, or secant, and that is the hypotenuse over the adjacent. And then this one is called cotangent, which is the adjacent over the opposite. So these other three functions create the total 6 trig functions that we're learning about in 9.1. That's the basic notes. I'm going to do a couple more examples where I will point out exactly what the numbers would be, but otherwise, that's it for today. Study these, learn these, know them, love them, all that. Okay? Talk to you later.